In this video, we'll write the balanced net ionic equation for AgNO3 plus K2CO3. This is silver nitrate plus potassium carbonate. So the first thing we need to do is balance the molecular equation. I have these two silver atoms here and just one here. I'm going to put a 2 in front of the AgNO3. Now I have two silver, but I have two nitrate. If I put a 2 here, two nitrates, two potassiums, that's good. I have two potassiums here, carbonate and carbonate. So this is the balanced molecular equation. Now we need to write the states for each substance. So you know your solubility rules. Nitrates are very soluble, as are potassium compounds. So when I get to the carbonate here, carbonates are often insoluble, especially like something like silver. Silver compounds are often insoluble as well. So the potassium carbonate, potassiums in group 1 like sodium, those are soluble. But when I see something like silver in the carbonate, I know that that's going to be insoluble, so it won't dissolve. I write S. These react, falls to the bottom of the test tube, precipitation reaction. And then nitrates, again, very soluble. So these are the states for our net ionic equation. Now we can split the strong electrolytes into ions for the complete ionic equation. Silver is a transition metal, but it's always a 1+. So I have two silver ions, and I won't write the states now. Let's write those at the end. And then the nitrate, the whole thing is 1-. Good one to remember. And I have two nitrate ions. Potassium, that's in group 1, 1+, and the whole carbonate is 2-. So I have two potassium ions, and then just the one carbonate. So these are the reactants in our net ionic equation. For the products, solids, we don't split solids apart in net ionic equations. So we just write Ag2CO3. Then for the potassium nitrate, plus and minus, so two potassium ions, just like the reactants, plus two nitrate ions. So this is our complete ionic equation. So now we can cross out spectator ions. They're on both sides of the complete ionic equation. I can see here in the reactants, I have two nitrate ions, and in the products, get rid of that. Reactants, two potassium ions, and in the products, two potassium ions. Those are gone. But what's left, that's the net ionic equation for AgNO3 plus K2CO3. Let me clean it up, write the states, we'll have our net ionic equation. So this is the balanced net ionic equation for silver nitrate plus potassium carbonate. You'll note that charge is balanced. We have 2 times 1+, that's 2+, 2-, they add up to a net charge of 0. And then our silver carbonate, it's neutral over here, net charge of 0 as well. If you count the atoms up, they're balanced too. This is Dr. B with the balanced net ionic equation for AgNO3 plus K2CO3. Thanks for watching.